On page 2 then, we have the applications of derivatives. It says the existence of extrema on a closed interval. A continuous function on a closed bounded interval takes on both a minimum and a maximum value on that interval. So what this theorem says right here is this says, like what we talked about earlier, if you have a continuous function on an interval, there must be an absolute max and an absolute min. So if I look at this first graph right here, it's going from this point to this point. Where is the absolute max going to occur? The absolute max is going to occur at what x value? It's going to be over here at 4. So this right up here, this is my absolute max. This is the highest point of the curve. Now, where would the absolute min occur? That's going to be on the other side, over here. This is my absolute minimum. The one thing we should make a note of is that absolute max and mins can occur at the endpoints. That's an important piece. So they can occur at the endpoints. If it was a relative max or min, you can't happen at an endpoint. Okay, it's just an absolute. And this point right here, it's not an absolute max, but what we're going to call this is what's going to call, and it's defined down here as a local extrema, or the other term that they'll use is a relative max. This is a maximum for a specific interval that's close to that point. And the other low point here we would call a relative minimum. But the idea here is the first diagram, we see that the absolute max and mins occur on the endpoints. How about the next diagram? Where would the absolute max occur on this second one over here? Absolute max occurs when x is what? X is 4. That's on the endpoint. So this is an absolute max. Where's the absolute min? It's over here again. So this is our absolute min. Okay, is there a relative max or min? No. In this case, we just have an absolute max and an absolute min. There are no relative max or mins on that diagram. Okay? So that's an important key to understand, is that it doesn't have to be a relative max or min on an interval, but there has to be absolute max and mins if it's a closed interval that we're talking about. Now, the definition below that relates to that, it's called the local extrema. Local, the word local could be relative. Same thing. Relative extrema, local extrema. So a relative min is going to occur if the functional value at C is the minimum value on some open interval in the domain of F containing C. So that means that we can look at the diagram right below here. There's got to be an interval. Let's say this is an open interval right here. Then this is considered a local minimum. That's the lowest point on an open interval. This spot right here, that's a local max from two values. It could be like from 3 to 5 or something like that. Here's a local min. That's going to be maybe from 6 to 8. That's a local min. Now, what can happen is that local mins or maxes can sometimes also be absolute max or mins. So like when I look at this diagram right here in this first one, this first point, it's considered a local min. What else do you think that might be? That's also going to be a absolute max. I mean absolute min. What am I saying? Okay. It's also an absolute minimum because it's on the lowest point on the curve. Okay. If this graph, and I'm assuming this graph has arrows going to the right, then that would not have an absolute max, but it would have a local max. Local max is right in that interval. Okay? In the second diagram, they're going to say this point right here is an absolute max on the closed interval from A to B. So if I just take this part of the graph and it's on a closed interval, then this point would be considered an absolute max because it's a closed interval. If you don't have the closed interval, then it's not considered a max. Simple as that. So, one thing to leave on this page right here, the last question it says, what are the slopes of the tangent lines at local extremas? So if you look at the tangent lines, what are the slopes? 0. And what do we remember? How do we get the slope in calculus? What do? We take the derivative. So really, it's the derivative of the function would have to be equal to 0. And that's going to be a key thing that we're going to use to help us identify absolute or relative max and mins on a graph.